process of mountain building is a complicated process that lasts hundreds of millions of years. To understand mountain building, we must first understand the rock cycle. Let's start off with the types of rocks. Sedimentary rock is a type of rock that is formed by the compaction and cementation of eroded sediment. Metamorphic rock is any type of rock that has undergone extreme heat and pressure. And lastly, igneous rocks are formed by the cooling of magma on the Earth's surface. To start off the rock cycle, it is fueled by both solar energy above the Earth and internal heat coming from the asthenosphere below. Extrusive igneous rock undergoes weathering and erosion to form sediment, which goes through transportation and deposition, and lastly burial and lithification to form sedimentary rock. From here, sedimentary rock is able to form metamorphic rock through a process called metamorphism, which is heat and pressure, or go through melting to form magma, which cools to form extrusive igneous rock. Intrusive igneous rock reaches the surface of the Earth through eruption of magma, and metamorphic rock reaches the surface of the Earth through uplift due to mountain building. Mountains are formed as a result of Earth's tectonic plates coming together. The movement of plates on Earth's surface is fueled by convection currents, which is intense heat in the Earth's core.
Now that you've learned all about the rock cycle, I'm going to explain a process called folding. Folding occurs when the Earth's plates slide into one another and the crust is pushed up. This results in things called anticlines and synclines, also known as mountains and valleys. This process is easy to demonstrate in this simple experiment.
Purpose. The purpose of our experiment is to determine the movement of rock layers when undergoing converging plate movement and demonstrate the forming of mountains through this pressure. Hypothesis. Our hypothesis is that if we put convergent pressure on layers of sand and flour in a box, some of the layers will bend into folds and slide over each other in faults, and the pressures will make mountains.
To do this, you will need a clear box or container, flour, sand, a piece of cardboard or cardstock, and a spoon. What you're going to do is place the cardboard along one side of your box or container. Then you're going to add one layer of sand to the base of your box that's about 1 centimeter thick. Okay, stop. Now, on top of the layer of sand, you're going to add one layer of flour. Okay, now you can see that you have layers of sand and flour. So what you're going to do is drag your cardboard along the base of your box slowly until it's about halfway through. Stop. Okay. Now you can see how this movement has affected the layers of flour and sand. You can see that the layers that were once all straight and parallel, now some of them are higher than the others. With this experiment, you can see the effect of folding that occurs in the Earth. These are the layers of the Earth that fold to form mountains and valleys. Up here would be the top of a mountain, and down here would be a valley. You can see how the anticlines and synclines I have mentioned before have formed. The top here is the anticline, and the synclines are down here.
Observations. In our experiment, we observed that pushing the board caused the layers to bend and break, just like what happens to rock layers through folding and faulting in plate tectonics. The layers formed mountain-like structures. Conclusions. In our experiment, the flour and sand represented rock layers in the earth, while the cardboard represented a plate undergoing convergent plate movement. The bending of the layers of sand and flour simulated folding and faulting of rock, which ultimately creates mountains.